Much of what's presented in this video are well-founded assumptions. They might not come to fruition, but that's the foundation upon which all science is built. Today, we will delve deeper into the abyss of potential madness than ever before. Many have heard that the age of our universe is around 13.8 billion years, and that it appeared as a result of the Big Bang. But the question here is what we call the universe, and what does the beginning mean? When you hear the phrase "the universe appeared out of nothing," it rather means nothing of what we cannot describe. Moreover, theoretical physicist Matt Strassler, in his article Hot Big Bang, writes that when we talk about the age of the universe, we are only talking about the period from the beginning of the Big Bang to our days. But that does not mean that there was nothing before the Big Bang. And exactly the same applies not only to time, but also to space itself. It is assumed that the universe was concentrated in an infinitely small point at the moment of the Big Bang and had a finite size, like less than one atom, or whatever they usually say in popular science shows. But we are only talking about the visible part of the universe. Thus, this does not mean that at the moment of the Big Bang the universe was not infinite. In fact, all data tells us precisely that the universe is indeed infinite. And that means it was much denser but still infinite from the very beginning. Infinity is one of those things that you shouldn't think about too much, or else terror may overwhelm you. Soon everything said will become a little clearer to you. In August 1881, Friedrich Nietzsche was walking along Silvaplana Lake near the village of Surlay in Switzerland and stopped to rest near this rock. At that very moment, the philosopher was struck by a revelation that nearly crushed him. As he later expressed in a letter to his friend Peter Gast, "A thought has risen on my horizon, the like of which I have not known before." This moment was so significant that it was immortalized by this plaque on the rock. The quote literally reads, "I stopped by a massive pyramidal block not far from Surlay. It was then that this thought came to my mind." Nietzsche realized that the idea that struck him should become the central theme of his philosophical teachings, but at the same time, the most terrifying. So horrifying that he was very reluctant to talk about it. Many who knew him well, in particular his friend Franz Overbeck and his unrequited love Lou Andrea Salome, later reported that Nietzsche spoke of this idea in whispers and implied an unprecedented discovery. According to Friedrich Nietzsche, this thought would only not be devastating when properly understood by the so-called Übermensch or Superman. Superman is not some comic book character, but an image introduced by himself to denote a being that, in its power, should surpass modern man as much as the latter has surpassed the ape. And speaking of power, it's more about psychological qualities. We will get to the very thought that illuminated Nietzsche, but first, I will have to explain a lot to you. Let's start with the fact that I'm now going to tell you about one of the most astonishing cosmological oddities I know. You know that the farther an object is from us, the smaller it appears to us. For example, from a bird's eye view, people look very small. The same thing happens in the nearest part of space. The sun is 400 times larger than the moon, but during a total solar eclipse, the moon almost perfectly covers it, as it is 400 times closer to us than our star. And this regularity with the change in size, depending on the distance, is maintained over billions of light years. So, the farther away a galaxy is, the smaller it appears to us, as one would expect. However, at some point, at a distance of about 14 billion light years, suddenly the exact opposite principle starts to apply. Specifically, the farther away an object is, the larger it appears. And there's a simple, but at the same time, extremely sad explanation for this. Let's start with the fact that, as hard as it is to believe, when you look at any star or galaxy in the night sky, you are directly experiencing the gravitational effect of that object at that very moment. Even if that object is far away from you, if you see it, its gravitational field reaches you because gravity travels at the speed of light. You not only see the sun as it was 8 minutes and 20 seconds ago, but our entire planet is also attracted not to where the sun is now, but to where it was those same 8 minutes and 20 seconds ago. The peculiarity of gravity is that although it weakens with distance, it never reaches zero. I'm not sure that the gravitational effect of very distant objects can even be registered at all. To understand how weak gravity is, here's a trivial example. When you pick up your phone, you are overcoming the gravity of the entire planet. However, the force of gravity would be enough to cause all the massive objects in our universe to collapse sooner or later. You would never be able to move away from an object far enough not to experience its gravitational effect at some level. But nevertheless, our universe does not collapse. In fact, something completely opposite is happening. We don't know why, but the universe is expanding and doing so at an accelerating rate. And since physicists have no idea what causes the universe to expand, they usually refer to any hypothetical phenomenon capable of accelerating the expansion of the universe as dark energy. Yes, I know you're tired of hearing about dark energy from every other space video, but dark energy appears to be one of the most repulsive phenomena in existence. Cosmologist Catherine Mack writes, "If you ask my colleagues, they'll tell you they seek to understand the nature of dark energy, because it can tell us a lot about fundamental physics and our cosmological model. But I know that in reality, they're driven by fear." So, the expansion of the universe. If we wind the clock back 13.8 billion years, right to the very conditional beginning, we encounter a paradoxical moment when, for some reasons not entirely clear to us, the expansion of the universe suddenly accelerated. And the region that was to become our observable universe expanded in size by more than 100 trillion times. This happened much faster than the speed of light, because there are no limitations on the speed of space expansion itself. I understand our brains can't really grasp these figures, but for some visualization, here's what theoretical physicist Matt Strassler, whom I mentioned earlier, writes. How insane is this rate of expansion? A patch of the universe no larger than your computer screen expanded to the size of the observable patch of the universe, or larger, in less than the time it takes for a quark to cross from one side of proton to the other. But then this monstrous expansion, for reasons still unclear, slowed down. This is referred to as cosmic inflation. It's uncertain whether that initial expansion is related to the expansion we observe now, but the main point is, we have no reason to claim that cosmic inflation can't happen again. For instance, right now, as you watch this video, we wouldn't even have time to understand what's happening. If such a thing occurred, it would be horrifying. Yet the simple disappearance of humanity wouldn't be the worst scenario. You might ask, what could be worse for humanity than the annihilation of all humanity? So, we continue. The universe went through an inflation phase, after which the expansion slowed down, but about 6 billion years ago, the expansion began to accelerate again. You've likely heard that the universe isn't expanding from a specific point, but is expanding everywhere at once. Therefore, the farther an object is, the faster it moves away from us. If that's hard to understand, consider this simple analogy. The slinky. Each coil of the slinky only moves away from its neighbor by the width of a finger, but two coils at its opposite ends move more than a meter apart from each other. Now imagine an infinite slinky. This is precisely what's happening with galaxies in the universe. Due to this mechanism, distant galaxies can move away from us at the speed of light or even faster. Because, as a reminder, there are no limits to the speed at which space expands. And it's this expansion of space that causes objects at a certain distance from us to appear larger the farther they are. This phenomenon occurs for the same reason we can observe objects currently moving away from us at supersonic speeds due to space expansion. When these objects emitted their light, they were much closer and occupied a larger portion of the sky because the universe itself was denser. Even though they are much farther away now, the snapshot they sent us has been traveling all this time, and due to the universe's expansion speed slowing down for a while, as you may recall, this snapshot finally reached us, showing ghostly images of a much closer and much older object. Thus, the farther back in time we look, the more compact a universe we observe. Therefore, a galaxy that is now farther away than another galaxy might have been closer when emitting its light. This gives rise to a paradox of perception. You've probably been waiting for this. Here's a real example. One of the farthest galaxies we've ever observed, GNZ11. The ghostly snapshot we see has been traveling towards us for approximately 13.5 billion years. Thus, it appears to us that this galaxy is much closer, but in fact, when we look at it, we're essentially seeing the universe, as it was only 400 million years after the Big Bang. Remember, it was much more compact then. Moreover, due to the expansion of the universe, GNZ11 is about 32 billion light-years away from us. It actually appears twice as large as a galaxy of the same size that's twice as close. A paradox of perception. You know that a light-year is the distance light travels in 1 year. Given that the universe has been around since the Big Bang for 13.8 billion years, one might assume we should only be able to see up to 13.8 billion light-years away. But in reality, because of dark energy, we can see much farther, which isn't a secret for many of you. Currently, the farthest distance we can observe is a sphere with a radius of 46 billion light years. And that's just for now. This sphere will continue to grow due to the expansion of space, but only up to a certain limit. After some calculations, we find that the future observable limit will be roughly 33% greater than the current, or about 61 billion light years away from us. However, the image of GNZ11 will gradually fade and eventually disappear forever. As you've understood, the light that this galaxy emits now will never reach us unless the expansion slows down again. At present, GNZ11 is moving away from us at a speed of 687,000 kilometers per second, more than twice the speed of light. It's sad, but what's even sadder is that GNZ11 isn't the only one. Think about it. Over 96.7% of the galaxies we can observe today have already disappeared by the same principle. 98.6% of galaxies we will ever observe are already gone. In other words, in the future, we're set to observe a total of 4.7 trillion galaxies, and 4.634 trillion of them are already forever out of our reach. Even if we could move towards them at the speed of light, only about 66 billion galaxies are still accessible to us today. I emphasize today, because this problem will only worsen over time. Right now, assuming each of the 66 billion galaxies has as many stars as the Milky Way, about 400 billion, that means approximately 60,000 stars are disappearing from our field of vision every second. So since you started watching this video, around 50 million stars have vanished from our sight forever. We'll still be able to see their old light for billions of years, but any new light they emit from this moment on will never reach us again. We're no longer connected to these objects in any way. Regardless of what we do from this point on, we'll never influence them again, just as they can't influence us. Any information about these places is now fundamentally inaccessible to us. Even with the most advanced technology, over 98% of all the galaxies we will ever observe are already beyond our reach. If the force of space expansion can't overcome the gravitational force within galaxies, each galaxy or local galaxy group will slowly fade into darkness, left in complete solitude. Gradually, existing stars will burn out, particles will decay, black holes will evaporate due to Hawking radiation, and the universe will be nothing more than empty space, with only dark energy fueling its exponential expansion for eternity. It's worth noting that dark energy is kind of the opposite of gravity, meaning the more space is filled, the stronger the force of gravity, and the emptier the space, the stronger the dark energy. Because even though it operates subtly, its density per square meter doesn't decrease with the expansion of space. So, you see what's happening. With the accelerating process of the universe's expansion, there will be more and more empty space, which in turn will speed up the expansion process, leading to more empty space, and this will continue infinitely. Events in one part of the universe will not be able to influence events in others. Ultimately, the universe will become an empty space, with only dark energy driving its exponential expansion. This is called de Sitter space, and according to physicists, it evolves similarly to the very early cosmos during the inflation phase. However, unlike inflation, this expansion will continue indefinitely. Can we consider this infinite expansion the end of the universe? The question is, what do we define as the universe, and what do we mean by its end? For instance, if we consider the concept of time, it turns out to be one of the unsolved mysteries of physics. Nobody knows why it should flow in a particular direction. Look, do these particles move into the future or the past? You don't know the answer because regardless of which way I play this animation, the laws governing the movement of these particles remain unchanged. Physical processes at the microscopic level are believed to be either fully or predominantly time-symmetric. If the direction of time were reversed, changing the time direction in the equations would not affect the outcome. The theoretical statements describing them would remain accurate. You've just observed this. Now, observe something else. Is this paint separating from water or mixing with it? Here, you certainly know where the past and the future are, because at the macro level, there is a clear direction of time. Thus, it seems the only part of physics that takes time's direction into account is entropy. Why does your wardrobe become a complete mess sometime after you've organized it? Picture your wardrobe and imagine all possible ways to neatly arrange items inside. Now visualize all the possible ways to arrange them messily. Because there are many more messy arrangements, the probability that the system called a wardrobe with clothes will gradually become more and more chaotic is higher than the chance that this system will continue to maintain some orderly form. Due to the second law of thermodynamics, which states that in an isolated system, the total entropy cannot decrease, your wardrobe will, sooner or later, become disorganized again. You might say, I organized my clothes, so I reduced the entropy inside the wardrobe. Did I break the laws of physics? No, because the wardrobe isn't an isolated system. You expended a lot of energy cleaning up. You digested food, released heat and carbon dioxide, and more. So the overall entropy increased even more. By the way, this is why if you try to cool a room by leaving the refrigerator door open, the room won't get colder, it will actually get warmer. Every attempt we make to organize a part of the world creates disorder in another part, usually in the form of heat. We don't know this for certain yet, but perhaps entropy is what creates what we call time. Everything you see right now, galaxies, stars, people, is all a result of the universe being in an improbably ordered state at the time of the Big Bang. The gradual progression from that initial ordered state to a disordered one is what we call the passage of time, much like the mixing of paint in water. Just as we wouldn't be able to determine which direction time flows in footage of paint that has fully mixed with water, in a universe that has reached maximum entropy, the concept of the arrow of time ceases to exist. The fact that you perceive the arrow of time as pointing in a consistent direction, or the flow of time, indicates that the universe has not yet reached the equilibrium state it is trending towards according to the law of entropy. Once the universe reaches the de Sitter state, it will have maximum entropy because from that point on, the total entropy of the universe can no longer increase. This means nothing else can happen in the usual sense. For something to happen, energy needs to move from one place to another. But alas, the paint in the water has completely dispersed. In a way, a synonym for entropy is homogeneity. Given that the universe is expanding not from a single point, but at every point simultaneously, when it reaches the stage of exponential expansion, one could delineate a sphere around any point. Beyond this boundary, a forever hidden part of space would exist, just as there are stars now forever hidden from us, and this is known as the heat death of the universe. You might ask, why did you say it's worse than the extinction of humanity? By the time of the heat death, we would have been gone for so long that it wouldn't matter. But there's a twist that changes everything. Ask yourself two questions. First, what happens when you have an infinite amount of time? And second, what happens when you have an infinite amount of space? The answer to both these questions: everything. Literally everything within the confines of the laws of physics. Could I suffocate because all the oxygen in my room gathers in one corner? Never. Entropy protects me from this situation because, as you remember, there are far more disordered states than ordered ones. Thus, no investigator would even consider such a cause of my death. But in reality, when we say never, we often mean usually. Decreasing the disorder in a system is possible, but it's highly improbable. People typically don't suffocate because all the oxygen gathers in one corner of the room. But if I were to sit here for an infinite amount of time, it would happen with a 100% probability. At first glance, an entirely empty universe might seem void, but even where there are no particles, quantum fields still exist, and they never behave entirely quietly. Quantum fields don't maintain a constant value. Their value at any point in space always fluctuates a little. These fluctuations are called quantum fluctuations. They are nothing more than the consequences of the famous Heisenberg's uncertainty principle. On a quantum level, or even on larger scales if you're willing to wait long enough, and by long I mean very long, every once in a while, truly bizarre things occur due to unpredictable fluctuations that can shift a portion of the system into a state of lower entropy, greater homogeneity. Therefore, even if we believe that the universe had a beginning and is not infinite in space, in the expanding universe, there is so much time and space that extremely unlikely events can and will happen with 100% certainty. It's improbable that an entire piano would spontaneously assemble in empty space. However, in an article, the link to which I'll leave in the description, Physicists calculated that if you wait for a period that's a trillion times longer than the age of the universe, you'd see it appear right before your eyes. The less probable an event, the longer you'd have to wait. But if you have infinite space or infinite time, or even more so, if you have both, then any improbable event will happen an infinite number of times. The implication we can derive from the hypothesis of the universe's heat death can horrify, making anyone who deeply ponders it reevaluate. The thought that pierced Friedrich Nietzsche, which I mentioned at the start of the video. A few months after this realization, he will write the book The Gay Science, where he will very cautiously touch upon his idea at the very end, in the penultimate excerpt, which he will call The Heaviest Weight. What if some day or night a demon were to steal into your loneliest loneliness and say to you, "This life as you now live it and have lived it, you will have to live once again and innumerable times again, and there will be nothing new in it, but every pain and every joy and every thought and sigh, and everything unspeakably small or great in your life must return to you, all in the same succession and sequence, even this spider and this moonlight between the trees, and even this moment and I myself. The eternal hourglass of existence is turned over again and again, and you with it, speck of dust. Would you not throw yourself down and gnash your teeth and curse the demon who spoke thus? Or have you once experienced a tremendous moment when you would have answered him, 'You are a god, and never have I heard anything more divine'? If this thought gained power over you, as you are, it would transform and possibly crush you. The question in each and every thing, do you want this again and innumerable times again, would lie on your actions as the heaviest weight. Or how well disposed would you have to become to yourself and to life to long for nothing more fervently than for this ultimate eternal confirmation and seal? The last excerpt of this book was titled The Tragedy Begins, and this same excerpt would become the preface to Nietzsche's magnum opus. Thus spoke Zarathustra. The central idea of the book was conceived as the eternal recurrence. The concept of eternal recurrence asserts that time repeats in an infinite cycle, and the same events will continue to happen in the exact same manner over and over for eternity. In formulating this concept, he probably proceeded from the following premises. If the universe is infinite in time, and the amount of matter within it is fixed, then sooner or later, any combinations of this matter will repeat exactly. Even if he was far from today's cosmological theories, his conclusion might be accurate because this conclusion is physically plausible based on the de Sitter equilibrium hypothesis proposed by Andreas Albrecht. The main idea of this equilibrium version of de Sitter space is that the origin of our universe and everything happening within it can be viewed as the result of random fluctuations in an eternally expanding space containing only dark energy. At some point, due to quantum processes, there's a leap into a very low entropy state in this space. A universe emerges, which then gradually returns to its regular high entropy state, once again becoming a de Sitter universe. Just as the oxygen, if it were in one corner, would eventually distribute evenly throughout the room again, and everything would repeat in a cycle for all eternity. Of course, no one is suggesting that every specific Big Bang would reproduce the history of our universe identically. But that's the horror of infinity. Given infinite time, our universe would eventually recur with any degree of precision. And you'll be watching this video, and this will occur an infinite number of times. Moreover, given the infinite de Sitter space, Big Bangs evolving precisely into our universes are happening at every moment an infinite number of times. This entire process is described by a model of the universe called eternal inflation. I apologize for slightly deviating from the main topic of this video, but we so casually and easily talk about eternity or infinity without truly contemplating what these concepts genuinely entail. You might again say, why should we care? No matter how many times the universe repeats, it won't be us. But then the question arises, what does it mean to be you? Often you hear from people who consider themselves non-religious that life is singular and that we live only once. But isn't this assertion more religious than the opposite? In other words, these people are saying that their consciousness is fundamentally impossible to recreate. This is a strong claim because if you break it down, it suggests that consciousness is something detached from the material world. How long does it take for a new Big Bang? There are some calculations that suggest inflation will trigger a new Big Bang in approximately 10 to the power of 10 to the power of 10 to the power of 56 years. And if an entire universe can emerge from a vacuum due to quantum fluctuations, then with much higher probability, an individual galaxy can do the same since it's less complex and requires less matter to form. Following this logic, it's more likely for a single solar system to emerge, and even more probable for a single planet, or even just today, this very moment, and all the other moments of your life. In reality, it's even more likely for an individual thinking structure, a human brain, to emerge, which contains all your memories and imagines it's living in a vast, complex world, and is currently watching this video in which I present hypotheses that probably cannot be tested. You don't notice this illusion because for you, as an observer, there is no space or time beyond your consciousness. If you suspect I'm spouting nonsense, many generations of scientists have pondered over such ideas. The concept of a brain spontaneously appearing in a void is called the Boltzmann brain. This idea gained new relevance around 2002, when some cosmologists began to worry that in many theories about the universe, a human brain arises far more often as a result of random fluctuations than the emergence of an entire universe, which would then undergo evolution leading to humans, simply because the fluctuation-caused appearance of a separate brain is much more probable. If a new universe, as you remember, appears once in 10 to the power of 10 to the power of 10 to the power of 56 years, then a Boltzmann brain appears just once in 10 to the power of 10 to the power of 50 years. This leads to the statistical probability that people are likely mistaken about their past memories and are actually unfortunate Boltzmann brains, constantly emerging in an empty universe and doomed to almost instantaneous destruction. The Boltzmann brain is practically nothing compared to what the universe is capable of generating in an eternal inflation model. But I won't continue giving examples, and I don't recommend you do either. Even if you or I aren't Boltzmann brains, such ideas are captivating. Considering the staggering number of parameters that had to align for human consciousness to emerge, as I discussed in the previous video. Looking at this, one can't help but wonder if infinite time or space plays a part. The idea of fluctuations contradicts our understanding of the rational structure of the cosmos so deeply that leading cosmologist Sean Carroll termed it cognitively unstable. It's not that this can't be true. It's that if it is, then we might as well give up any attempts to understand the universe, because nothing makes sense. And Friedrich Nietzsche is often referred to as a nihilistic philosopher because his philosophy negated life. This is perhaps the most absurd thing one could say about his philosophy. If the teaching of eternal recurrence leads to the meaninglessness of events, then the doctrine of the Übermensch, as formulated in Thus Spoke Zarathustra, should serve as a sort of mandate directed at human will to ensure such meaning exists. The merciless idea of eternal return rules out any hope of an afterlife or any consolation. But Nietzsche believed that it was the Übermensch who had the courage to say a loud and confident yes to such a world, leaving behind all the illusory hopes offered by religion, science, and philosophy. Nietzsche himself did not consider himself to be the Übermensch. For him, who had a tragic fate filled with pain and suffering, the idea of eternal recurrence was devastating, paralyzing, and utterly horrifying. In his notes, he wrote, "I don't want to start life over. Where would I find the strength to endure it? By creating the Übermensch and looking up to him, hearing him say yes to life, I, alas, trying to say yes myself." Perhaps this is why Nietzsche only alludes to his most profound idea in one excerpt from The Gay Science, in two passages from Thus Spoke Zarathustra, and once in The Will to Power, as if he dared not look this idea in the face for too long. 8 years after his enlightenment, and the most productive period of his life, he went insane. There are various theories about why this happened, including insomnia medications, heredity, schizophrenia, and so on, but there is no consensus on the matter. Some even genuinely believe that Friedrich Nietzsche's madness had a psychogenic origin. Regardless, the disease did not leave the philosopher, and on August 25, 1900, he died in complete insanity. Fortunately for him, and for all people, the heat death of the universe is just one of the 5 possible scenarios described in Catherine Mack's book, The End of Everything, which inspired this video. Not every scenario implies the hypothetical possibility of eternal return. Theoretical physicist Freeman Dyson, known to the general public for the Dyson sphere, sharply criticized the physics community in his article Time Without End for neglecting the topic of the end of the universe, indicating a lack of serious works on the subject. He wrote, "The study of the remote future still seems to be as disreputable today as the study of the remote past was 30 years ago. If our analysis of the long-range future leads us to raise questions related to the ultimate meaning and purpose of life, then let us examine these questions boldly and without embarrassment. However, based on what we've heard today, maybe it's best not to. But then again, you should remember that much of what is in this video is merely well-founded speculation that might not be confirmed." Before we wrap up, if you enjoyed this video, I would be truly grateful if you could give it a thumbs up and leave a comment. If you'd like to support me financially, I've set up a Patreon. Your support there would significantly help the growth of the channel. On Patreon, videos will be released a day earlier than on YouTube. Occasionally, I'll also share short articles on topics I find intriguing, but not quite suitable for a full YouTube episode. Additionally, you'll receive announcements about the themes of upcoming videos and have the ability to vote on new video topics. Thank you for watching.